The Sun, an immense glowing ball of incandescent plasma, is the powerhouse at the center of our solar system, fueling all life on Earth with its unstoppable energy. For over 4.6 billion years, this blazing star has bathed our planet in warmth and light, making Earth a vibrant oasis in the vast cosmic desert. Join us as we journey deep into the Sun's core, where nuclear fusion unleashes mind-boggling energy, powering solar storms and illuminating space with breathtaking flares and sunspots. Witness the incredible dance of charged particles and magnetic fields that sculpt majestic solar prominences and explosive coronal mass ejections, painting the sky with mesmerizing auroras. Our story begins billions of years ago in a cosmic cloud of gas and dust, the solar nebula. Gravity's relentless pull compressed this cloud, triggering nuclear fusion in its heart and igniting the Sun's brilliant light. This fusion furnace fuses hydrogen atoms into helium, releasing energy so immense it powers the entire solar system. Within the Sun lies a complex engine, the core, where fusion births energy, the radiative zone, a glowing tunnel of photon energy bouncing for tens of thousands of years, the majestic convective zone, a roiling sea of plasma currents endlessly churning upward, and finally a photosphere, the dazzling surface where light escapes into space. Dark sunspots spiral across the Sun's surface, cosmic storm centers where intense magnetic fields trap cooler gases. Suddenly, explosive solar flares burst forth, ejecting massive waves of energy and charged particles at colossal speeds, lighting up the cosmos and throwing spectacular auroras into Earth's polar skies. The Sun's energy is Earth's breath. It drives weather, powers the water cycle, and stabilizes the climate that nurtures life. Its magnetic dances shape the planet's auroras. Celestial light shows that remind us how deeply connected we are to our roaring star. Understanding our Sun, its power, patterns, and subtle mysteries, is key to unlocking the future of our planet and humanity's place in the cosmos. Our next chapters will take us through its life cycle, solar storm secrets, and the technologies protecting Earth from its sometimes volatile outbursts. Beneath the Sun's shimmering glow lies a landscape of restless turbulence, a roiling sea of plasma shaped by powerful magnetic fields. This dynamic surface, known as the photosphere, is a constantly shifting canvas where sunspots, solar prominences, and flares dance in a spectacular solar ballet. Sunspots are cooler, darker patches on the Sun's surface caused by intense magnetic activity. Though cooler than the surrounding area, they can be gigantic, some so large they could swallow Earth whole. These sunspots often herald the buildup of energy that can explosively release as solar flares. Solar flares are sudden bursts of intense radiation caused by the magnetic energy stored in the Sun's atmosphere snapping free. These powerful eruptions send waves of X-rays and charged particles hurtling through space at millions of miles per hour. Sometimes even more massive bursts, called coronal mass ejections, propel billions of tons of solar plasma into the solar system, impacting planets and spacecraft. The Sun's magnetic field governs much of this activity. Twisting and tangling like invisible ribbons, magnetic field lines build tension, storing energy that occasionally snaps violently, unleashing flares and reshaping the Sun's corona, the glowing outer atmosphere visible during solar eclipses. The corona itself is a mystery. It's millions of degrees hotter than the surface below, an enigma that puzzles scientists who study solar physics with spacecraft like the Parker Solar Probe and Solar Dynamics Observatory. The Sun's tempestuous activity has profound effects on Earth. When charged particles collide with our planet's magnetic field, they trigger shimmering auroras, the northern and southern lights, painting the skies with curtains of vibrant color. However, solar storms can also disrupt satellites, GPS, radio communications, and even power grids, reminding us that while the Sun sustains life, it also commands respect with its unpredictable temperament. Solar activity follows an approximately 11-year cycle, waxing and waning between solar minima and maxima. At the peak, the Sun brims with sunspots and energetic events. At the low, it calms. Scientists monitor this cycle closely to protect technology, astronauts, and Earth infrastructure from intense solar weather. Studying these solar phenomena not only helps safeguard modern technology but also unravels the mysteries of star behavior across the universe. Our Sun is an active star, a glowing heart whose moods ripple across the solar system. Sunlight, the invisible thread connecting the Sun to life on Earth, powers the very fabric of our ecosystem. This radiant energy drives photosynthesis, fuels weather patterns, and shapes climates across the globe. The Sun's energy is the ultimate source behind wind, rain, ocean currents, and seasonal changes, influencing every corner of our planet. Solar radiation warms the Earth unevenly, creating temperature gradients that drive atmospheric motion. This energy imbalance generates winds and storms, powering the water cycle that regulates the planet's freshwater supply. Changes in solar output, though subtle, can ripple through these systems, affecting climate patterns like El Niño and monsoons. Scientists study the Sun's irradiance and sunspot cycles to understand their influence on Earth's climate. During solar maxima, increased solar activity slightly boosts solar energy, while minima can produce temporary dips. While these fluctuations are minor compared to human impacts, they remain a critical piece of Earth's complex climate puzzle. Harnessing the Sun's power, humans have developed technologies to convert sunlight directly into electricity. Solar energy is a growing cornerstone of renewable energy solutions, reducing dependence on fossil fuels and helping combat climate change. From rooftop panels to vast solar farms, humanity increasingly embraces this clean, sustainable energy source. Yet, the Sun's influence extends beyond energy. Solar storms and geomagnetic disturbances can disrupt satellites, radio signals, and power grids, challenging our increasingly technology-dependent world. Space weather monitoring and forecasting have become vital to protecting infrastructure and astronauts from solar hazards. Global collaboration among space agencies and science institutions aims to improve our understanding of solar activity and enhance early warning systems. This knowledge safeguards vital technology and ensures humanity continues to thrive under the protective glow of our star. The Sun, like all stars, has a life story that began billions of years ago and will continue for billions more. It was born from a vast cloud of gas and dust, known as a molecular cloud, that collapsed under gravity to ignite nuclear fusion at its core. Currently, the Sun is in the prime of its life, a stable middle-aged star known as a yellow dwarf, steadily burning hydrogen into helium to shine brilliantly for approximately 10 billion years. This star's life is governed by the delicate balance between gravity pulling inward and the explosive pressure from fusion reactions pushing outward. This equilibrium keeps the Sun's size and energy output remarkably consistent, providing a stable environment for life on Earth. As hydrogen runs low in the core, the Sun will begin a dramatic transformation. Expanding into a red giant, it will swell to many times its current size, possibly engulfing the inner planets, including Earth, transforming the solar system dramatically. Eventually, the Sun will shed its outer layers, forming a glowing shell of gas called a planetary nebula. The remaining core will cool and shrink into a dense white dwarf, a small, fading ember marking the final stage of the Sun's stellar life. Though these changes lie billions of years away, understanding the Sun's life cycle offers vital insights into the fate of Earth and the broader cosmos. It also informs how other stars live and die, shaping galaxies and seeding the universe with the elements essential for life. Scientists continue to study our star's life and activity using solar observatories and powerful simulations, deepening our knowledge of stellar physics and helping us prepare for the Sun's future, ensuring humanity remains connected to the star that gave it birth. This powerful outflow shapes the space environment throughout the solar system, carrying magnetic fields and energetic particles that interact with planets, comets, and spacecraft. The solar wind emanates from the Sun's outer atmosphere, the corona, flowing outward at speeds sometimes exceeding 1 million miles per hour, influencing not only Earth but the entire heliosphere, the protective bubble surrounding our solar system. When the solar wind meets Earth's magnetic shield, it creates a dynamic interaction zone, deflecting harmful particles while funneling some toward the poles. At the same time, strong solar storms can disturb Earth's magnetic field, causing geomagnetic storms that impact satellite operations, GPS navigation, radio communications, and even terrestrial power grids. Among the most dramatic space weather events are coronal mass ejections, massive bursts of solar plasma and magnetic fields hurled into space. When these reach Earth, they can induce powerful geomagnetic storms, posing risks to astronauts, satellites, and ground-based technologies. To protect modern infrastructure and space missions, scientists use satellites like the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe to monitor solar activity in real time, issuing early warnings of incoming space weather. International collaboration plays a key role in understanding and mitigating space weather risks. Ground and space-based observatories coordinate to track solar activity, ensuring power companies, airlines, and space agencies can take precautions during solar storms. The solar wind also sculpts planetary atmospheres and shapes tails of comets, making it a fundamental force in the architecture of our solar system. Its relentless flow extends to the heliopause, where the sun's influence finally meets interstellar space. Understanding solar wind and space weather not only guards our technology and astronauts, but also enriches our knowledge of stars like the Sun and their impact on the habitability of planets across the universe. The Sun is not just a star, it's the heart of our cosmic neighborhood. Its energy has shaped the origin and evolution of life on Earth, driving ecosystems, weather, and climates. As our knowledge expands, the Sun continues to inspire technology, exploration, and hope for humanity's future among the stars. Harnessing solar energy is key to humanity's ambitions in space. Concepts like solar sails use sunlight itself as propulsion, while solar power fuels space stations and future colonies on the Moon and Mars. The Sun's influence reaches far beyond Earth, powering the engines of our interplanetary dreams. Cutting-edge missions such as NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter Probe, the Sun closer than ever before, unraveling mysteries of solar activity and space weather. This vital research protects technologies, astronauts, and advances our understanding of stellar physics. As we venture further, the Sun stands as both a life-giver and a challenge, providing energy and warmth, yet also posing risks through solar storms. Our future depends on understanding and adapting to the star's moods as we build sustainable space habitats and explore new worlds. From ancient myths to modern science, the Sun has been a constant companion and a guide. It reminds us of our place in the universe, our shared origin, and the potential to reach beyond. With every sunrise, the Sun ignites the spark of exploration that propels humanity toward new horizons. This is the Sun's legacy, a luminous beacon lighting the path for all life, transforming our planet and fueling our cosmic journey. As we move forward, let us embrace the boundless possibilities this star offers, continuing our voyage among the stars, forever illuminated by its radiant light.